Good morning, everyone. I am Dr. U. Shakti, working as assistant professor in Computational Intelligence Department. Today, I am going to take about bubble shot. What is bubble shot? How it works? What's the algorithm for bubble shot? And example of bubble shot and the time complexity and space complexity of bubble shot. We'll see one by one. First, bubble shot. Bubble shot is the simplest algorithm to sort elements in ascending and descending order. It's very easy to implement. How it works? This approach works by repeatedly swapping the adjacent element if the elements are not in order. So here, swapping, comparison and swapping is a two important operation in bubble shot. Two adjacent elements are compared. If the successor is greater than the predecessor, we can leave the element as it is. If the successor is lesser than the predecessor, swap the elements so that can be in ascending order. The smallest element moved to the front. The movement of array elements is just like the movement of air bubble in the water is called as bubble shot. That is, the smallest element is moved towards the left side, and the largest elements are moved towards the right end. So that is the concept of bubble shot. It is efficient only for smaller data sets, and bubble shot is not efficient or not suitable for larger data sets. So bubble shot operation, how it works? So it contains two basic operations, that is comparison and swapping. For example, there are two cases, case A and case B. So ARR is the array name. It, for example, it has two elements, 5 and 4. The values are not in ascending order. So J is 4 and the next location J plus 1 is 4, J is 5. So compare J and J plus 1. So in ascending order, first element should be less than the second element. So the A of J plus 1 is lesser than the A of J. Swap two elements. That is 4 comes in the first place and 5 comes after 4. So the elements are in sorted order. That is the case A. And the second case, the elements in already in sorted order. There is 4, 5, already in sorted order. So you compare J and J plus 1. J plus 1 is greater than J. So the elements are in already in sorted order. No need to swap. So here we are in this algorithm. It performs two basic operations: comparison and swapping. During comparison, the successor is lesser than the predecessor, swapping is performed. Otherwise, the elements are left as it is because already in ascending order. So we can go and fetch the next element. So these are the two cases. If you understand these two cases, it's very easy to implement. And bubble shot, iteration or passes. So n is number of elements in the array. And so number of iterations or number of passes is n minus 1. So the bubble shot is executed for n minus 1 iterations, where n is size of input. Each iteration, the largest element is moved to the last location. That is, after first iteration, the first largest element is moved to the last location and stored in the final correct place. And during second iteration, the second largest element is moved to the right and it is placed in the correct place. And this process is repeated for n minus 1 iterations to sort n elements. For example, see the table. Iteration 1, the maximum element is moved to the right end. And iteration 2, the second largest is moved to the right end before that is inserted in the correct place before the maximum value. And iteration 3, third largest element is moved to the right, that is before second largest and first largest. So this process is repeated for n minus 1 iterations. After n minus 1 iterations, the input array contains the elements in ascending order. So that is called bubble shot. So here n is number of elements, n minus 1 iterations or n minus 1 passes. At each iteration, the largest element is moved to the right and so on. And algorithm. Bubble sort is the name of the algorithm. Input is ARR, array name, index from 0 to n minus 1. So totally n elements, but the index starts from 0, so 0 to n minus 1. So what is the input? Array contains n elements in unsorted order. That is the elements to be sorted. Output. Our array ARR contains n elements that is sorted in sorted order. That is the output. And so what is the concept of bubble sort? Bubbling or moving the smallest element to the left side. So the smallest elements are moved to the left and largest elements are moved to the right. So that we are getting the sorted list. So here we are using two variables, two for loops. Initially I is equal to 1. So I is the loop variable for outer for loop and it values varies from 0 to n minus 1. For the second loop, we are using the loop variable j. J values varies from 0 to n minus 1 remaining elements. So we are taking the element, two adjacent elements. Adjacent elements are compared. If successor is lesser than the predecessor, swap successor and predecessor. That is swap j and j plus 1. So else increment j value. That is we can go for next location, next location. So after step 3 to 5 is for one iterations. For second iteration, again I increment I is incremented, again go to step 2. Now I value is equal to 1, second iterations. So that is I number of iterations is from 0 to n minus 2. So after two iterations, after n minus 1 iterations, two for loops output the sorted array. The sorted array ARR contains all the elements in sorted order. So this is the algorithm and example. So I am taking n equal to 5. There are 5 elements in the array. Index range from 0 to 4. So input array name is ARR. So in the first iteration, what's the range of I? I is used for outer for loop. So I is the number of iterations. I represents the current iteration. So I equal to 0 to n minus 2. So here n is, what's the n value? N equal to 5. So 5 minus 2 is 3. So I value varies from 0 to 3. That means 0, 1, 2, 3. So it performs 4 iterations. If number of element is 5, it performs 4 iterations. In general, if the number of elements in the array is n, algorithm performs n minus 1 iterations. So now we will see what is happening in each iterations. So iteration 1, j value varies from 0 to n minus 2. So 0 to 3. So if j is equal to 0, that is point 0th place we have 5 and j plus 1 is 12. So 5 and 12, j and j plus 1 is compared. So j plus 1 is greater than j. So 5 and 12, that is already in ascending order. No need to swap. Again, j equal to 1. Again, 12 and 6 is compared. Now 6 is lesser than the value 12. So j plus 1 is lesser than the j. Now swap the value. So in normally in ascending order, smallest number come first. That's called bubble sort, moving the minimum element to the left. So swap 6 and 12. 6 comes from left side and 12 goes towards the right side. This is called bubble sort. Smallest elements are moving towards the left side, and the largest elements are moving towards the right end. And if j is equal to 3, compare 4 and 1. J equal to 3, the last value 12 and 1. 12 and 1 is compared. Now 1 is less than 12. So swap 1 and 12. So 1 comes first, 12. So this is the first iteration of bubble sort. After first iteration, see the output, the maximum value in the array 12 that is moved to the last location, the correct place. This is the 12th value 12 at correct place. So this is the output of first iteration. And second iterations, so I equal to 1. So I equal to 0 is the first iteration, I equal to 1 is the second iteration. Again, j starts from 0 to 3. So j is equal to 0 and j equal to 0. So compare 5 and 6. So 6 is greater than 5. So the elements are already in sorted order. No need to swap. And increment j value, compare 4 and 1. So 4 is less than 6. Compare 4 and 6. 6 is greater than 4, so no need to swap. Already in sorted order. Again, increment j value. J is equal to 3 and compare 6 and 1. So 1 is lesser than 6. Swap the values. So 1 comes first, then 6 goes, move to the last place. Then compare 6 and 12, it's already in sorted order. So after second iteration, the second largest element 6 is placed in the correct place. So this is the final location of 6 and 12. This is the output of second iteration. So after two iterations, last two values are placed in the correct place. And iteration 3, so I value is 2. Again, j value starts from 0 to 3. Compare 5 and 4. So 4 is less than 5. So swap 4 and 5. Again, compare 1 and 5. 1 is less than 5. So move 1 to the second place and move 5 to the third place. So now j is equal to 2 and 3. So 5, 6, 12. Last three values are already in sorted order. So no need to swap. So after third iteration, third largest element 5 is placed in the correct location. Now the last iteration 4, where I is equal to 3. So I equal to 3. Again, the j value range from 0 to 3. So take j equal to 0. Fourth, compare 1 and 4. 1 is less than 4. Swap. So 1 comes first. 4 goes to the second place. Now, compare remaining 4 and 5. 5 is greater than 4. And again 5 and 6. 6 is greater than 5. Again 6 and 12. 12 is greater than 6. So no need to swap. The elements are already in sorted order. So after the fourth iterations, that is after n minus 1 iterations, all the elements are stored in sorted order. So the final output is 14562. So here the algorithm is performed in n minus 1 iterations. During each iteration, j value varies from 0 to n minus 1. So all adjacent nodes are values are compared. If the j plus 1 is lesser than j, swap j plus 1 j. Otherwise, go and take the next value. That is the working principle of bubble sort. And we will see implementation of bubble sort in C program. So here, see there asked one driver code in int main function. So main function, we have declared an array. Array contains 5 elements. So here in this program, we have initialized values in program itself. So when you implement in a lab, you can get the values for array from the user. During runtime, you can get input from the user. So you can write one more module. So void get array. So you can write one more module, get the values from the user. Then n is number of inputs. So bubble sort, call the functions. The function is called bubble sort. So how, see here, we have two for loops. I value varies from 0 to n minus 1, that is n minus 1 iterations. And for every value of I, j value varies from 0 to n minus I minus 1. That is n minus 1. Normally you are doing till the last element n minus 1. Why you are adding n minus I is after each iteration, the last element are placed in the correct place. So that cannot be compared again because already in sorted order, the first largest and second largest, third largest. After each iteration, the last element is in correct place. So for comparisons, we no need to take those values. So that we are changing the limit of j value. J less than n minus I minus 1. So compare a array of j with j plus 1. So if j plus 1 successor is lesser, swap a of I with a of j plus 1 using temporary variable. After swapping, go to the main function, print array, call the module print array. Now the values are printed in sorted order. So here in this bubble shot, we are using two for loops, and I is the index variable for outer for loop, j is the index variable for inner for loop. So for every value of I in each iterations, algorithm performs maximum n minus I minus 1 comparisons. Next, we will see the analysis of bubble shot. Time complexity means how much time it takes to complete the algorithm or to produce a result is called time complexity. There are three cases: best case, worst case, and average case. So, what is the best case situation in bubble shot? If the input is already in sorted order. So, sorted order, algorithm performs only n minus 1 comparisons because there is no swapping. Just for each iterations, only one comparisons. So that is the time complexity of best case is order of n. And the worst case, when the worst case situation occurs, if the input array is in descending order, the reverse order, algorithm performs maximum n into n minus 1 comparisons, where n minus 1 is number of iterations. And for each iterations, algorithm performs maximum n comparisons. So the time complexity is n into n minus 1. So in the notation, big O notations, the worst case and average case complexity is order of n square. So there are two cases in bubble shot. If the input is already in sorted order, algorithm performs only n minus 1 comparisons. Time complexity is order of n. In the worst case, the input is in reverse order. Algorithm performs n minus 1 iterations. In each iterations, algorithm performs n comparisons. So total comparisons will be multiplication of n into n minus 1, that is n square. So the worst case complexity and average case complexity of bubble shot is order of n square. And space complexity doesn't require bubble shot, does not require additional memory space. It is in place sorting algorithm. The input array ARR, all the operations are performed in the array itself. It doesn't require extra array or extra memory space for sorting. So the time space complexity of bubble shot is order of 1. It needs only one array. And comparison of insertion sort and bubble shot. So insertion sort and bubble shot, it works similar. Okay, so the time worst case complexity is order of n square for both insertion sort and bubble shot. Average case is also same for two algorithms, and best case, this is order of n. Best case is if the input is already in sorted order, it performs only n maximum n comparisons, that is order of n. So space complexity, both bubble shot and insertion sort is in place sorting algorithm. It does not require any extra array for sorting process. So this is the analysis of bubble shot. Normally, insertion sort and bubble shot is a simple algorithm for sorting. Normally, we are not using insertion sort or bubble sort because of its worst case complexity order of n square. Thank you.